All right, today in geometry, we're going to look at Algebra 1, Envision 7.2, multiplying polynomials. Our simple question, how does multiplying polynomials compare to multiplying integers? After today's lesson, you should be able to multiply two polynomials. So we're going to start out using multiplying a monomial and a trinomial using the distributive property. So number one says negative 4x cubed times x squared plus 3x minus 4. We simply want to distribute our negative 4x cubed to everything inside. So negative 4x cubed times x squared, so I get negative 4 times 1 is negative 4. X cubed times x squared, remember you add your exponents. So add exponents here. So x cubed times x squared becomes x, 3 plus 2 is x to the 5th. Negative 4x cubed times 3x gets me at negative 4 times 3 at negative 12. X cubed times x, 3 plus 1, x to the 4th. And then negative 4x cubed times negative 4 times negative 4 is plus 16, and then x cubed. That is our answer. It is in standard form, so negative 4x to the 5th minus 12x to the 4th plus 16x cubed. So number 2, we want to take negative 4x squared and multiply by 2x squared minus 3x plus 5. Again, we're simply going to distribute. Negative 4x squared times 2x squared gets me negative 8x to the 4th. Negative 4x squared times negative 3x gets me plus 12x cubed. Negative 4x squared times 5 gives me minus 20x squared. Again, that is our answer because it is in standard form. It's already highest exponent and then decreasing in order. And finally, number 3. Again, distribute. So negative 2x squared times x squared gets me negative 2x to the 4th. Negative 2x squared times 3x gets me minus 6x cubed. And negative 2x squared times times 4 minus 8x squared. That is in standard form, so that's our answer. So now we're going to look at using the distributive property to multiply two binomials. This is where the FOIL method comes in. FOIL means the first, the outer, the inner, the last. Then we will combine like terms and write in standard form. So the first two terms, so the first term in the first set of parentheses times the first term in the second set of parentheses. X times x gets me x squared. The outer, so the ones on the outside, x and 8. So when I multiply those, I get plus 8x. The ones on the inside, so 5 and x are inside, so that gets me 5x. And then the last, 5 times 8 gets me plus 40. So now I need to combine like terms, which are my 8x and my 5x. So I get x squared plus, so 8x plus 5x gets me plus 13x plus 40. That is our answer. It is in standard form. So number 2, 2x plus 4 times 5x plus 2. So do 2x times 5x to get 10x squared. 2x times 2 to get plus 4x. The inner, 4 times 5x plus 20x. And the last, 4 times 2 gets me plus 8. Combine our like terms. So I have 10x squared plus 24x plus 8. There's our answer. Number 3, 7x plus 2 times 2x minus 1. So our first, 7x times 2x gets me 14x squared. Our outer, 7x times negative 1, so minus 7x. Inner, 2 times 2x plus 4x. And our last, 2 times negative 1 minus 2. Combining our like terms, we end up with 14x squared minus 3x minus 2. That's our answer. Number 4, 5x minus 4 times 2x plus 1. So first, 5x times 2x, 10x squared. Outer, 5x times 1 plus 5x. Inner, negative 4 times 2x, negative 8x. And last, negative 4 times 1 minus 4. Combine like terms and we get 10x squared minus 3x minus 4. That is in standard form. There's our answer. Number 5 wants us to take 3x minus 5 times 2x plus 4. So our first terms, 3x times 2x gets us 6x squared. Our outer terms, 3x times 4 plus 12x. Our inner terms, negative 5 times 2x minus 10x. And our last terms, negative 5 times 4 minus 20. Combining terms, we end up with 6x squared plus 2x minus 20. Right, so that's how we multiply two binomials using the FOIL method. So now we're going to multiply a trinomial and a binomial. In order to do this, you multiply each term of the trinomial by each term of the binomial. Then we combine like terms and write in standard form. So number one, x squared plus 2x minus 1, all of that times 3x plus 1. So I'm going to take my x squared and I'm going to multiply it by both terms in the binomial. So x squared times 3x gets me 3x cubed, because again, I'm adding my exponents. Now x squared times the 4 gets me plus 4x squared. Now I move to the next term, 2x, and I multiply it by everything over there. So 2x times 3x gets me plus 6x squared. 2x times 4 plus 8x. Finally, take my negative 1 and multiply by everything over there. So I get negative 3x minus 4. Now I want to combine like terms. So I have x squareds to combine and x's. So I end up with 3x cubed plus 10x squared plus 5x minus 4. We are in standard form. So let's try that again. Number 2, 3x squared plus x plus 2, all of that times 2x plus 4. So multiply my 3x squared by everything over there. So I end up with 6x cubed plus 12x squared. Now take my x and multiply with everything over there. So I end up with plus 2x squared plus 4x. And finally, the 2 gets distributed, so then I end up with plus 4x plus 8. Combine my like terms, I get 6x cubed plus 14x squared plus 8x plus 8. That polynomial is our answer. Number 3, 2x minus 5 times negative 3x squared plus 4x minus 7. So this time the binomial is written first. I still do the same things. I'm going to take the first term in my binomial and multiply with all three terms in my trinomial. So 2x times negative 3x squared gets me negative 6x cubed. 2x times 4x gets me plus 8x squared. 2x times negative 7 minus 14x. Now I take the negative 5 and distribute. So I get plus 15x squared minus 20x plus 35. My last step, combine my like terms. So I get negative 6x cubed plus 23x squared minus 34x plus 35. There's our answer. Let's do one more of those. Negative 3x squared plus 1, all of that times 2x squared plus 3x minus 4. So distribute the negative 3x squared. We get negative 6x to the 4th minus 9x cubed plus 12x squared. Now I distribute the 1, so I get plus 2x squared plus 3x minus 4. Combine like terms, negative 6x to the 4th minus 9x cubed plus 14x squared plus 3x minus 4. And so now let's take everything that we've talked about today and do some application with that. So our problem says we have a smartphone that has a screen that has a width of x and a height that is 1.8 times the width. Okay, so that's where the 1.8x comes in. The outer dimensions of the phone are shown. Write an expression for the portion of the phone that is not occupied by the screen. And then it tells us assume that the phone is written. So if we find the area of the phone itself, that's length times width. So 1.8x plus 3 is the length times the width, x plus 1. So it's just binomial times binomial. So FOIL, so I get 1.8x squared plus 1.8x plus 3x plus 3. So the area of the phone, when I combine like terms, I get 1.8x squared plus 4.8x plus 3. And this is going to be square centimeters. Now I'm going to find the area of the screen. So the area of the screen, they told me up here that it has a width of x and a height of 1.8 times the width. So 1.8x is my height times my width x. And I multiply those, I get 1.8x squared square centimeters. So now the area that is not screen is going to equal the area of the entire phone. Sorry. Which was 1.8x squared plus 4.8x plus 3 minus the area of the screen, which was 1.8x squared. When I combine like terms here, my x squareds cancel, and I'm left with 4.8x plus 3. This is all square centimeters. So that expression gives me the area that is not occupied by the screen. All right, so now number 2. So suppose the height of the phone were 1.9 times the width, but all of the other conditions were the same. What expression would represent the area of the phone surface not occupied by the screen? Okay, so again, the area of the phone, this time it's going to be 1.9x plus 3 times x plus 1. FOIL method, we get 1.9x squared plus 1.9x plus 3x plus 3. So we would end up with 1.9x squared plus 4.9x plus 3 square centimeters. The area of the screen, 1.9x times x, get this 1.9x squared square centimeters. So the area not screen, again, the whole thing, 1.9x squared plus 4.9x plus 3, all of that minus the area of the screen, 1.9x squared. Again, my x squareds cancel, and I'm left with the expression 4.9x plus 3 square centimeters. That's how we would use an application. Okay? So that is a nice review of multiplying polynomials together using the distributive property, which is called the FOIL method if they are both binomials.